Second video in this unit, we're going to be covering going from tables to equations to graphs. And what I really want to stress is that these three things all represent the same equation. So if we're looking at the equation y equals 2x plus 1, and then we make a table from that equation that includes these 5 ordered pairs, and then we take those ordered pairs and we graph them, at no point did we change the equation. We are representing the same thing every single time. So when you're working on problems and you're doing equations, or you're doing tables, or you're doing graphs, remember that they're all the same and they can just help you solve different parts of the problem. So the first thing we're going to do is we're actually going to redo this problem and show how I got the answer that I just had up. So if I have y equals 2x plus 1, I need to plug in each of the inputs or the x values into the equation and see what y value is output. So for the first x value of negative 2, I'm going to plug it into my equation here. So I get 2 times negative 2 plus 1. 2 times negative 2, that's negative 4. Negative 4 plus 1 is negative 3. For my next input is negative 1, so I go 2 times negative 1 plus 1. This gives us negative 2 plus 1, which is negative 1. 0, if we insert here, gets 0 plus 1, which is 1. And then we should be able to see the pattern from here, that for each of these we're adding 2 if we're increasing our input by 1. So that gives us 1 comma 3 as an ordered pair, and 2 comma 5 as an ordered pair. The next step is to take each of these ordered pairs and to plug them or put them on the equation. So negative 2 comma negative 3 means we're going to go left 2 and down 3, and we make our ordered pair right there. The next one is negative 1 comma negative 1 right there. 0, 1. Surprisingly enough, the most commonly mixed up ordered pairs are when they're on one of the axes, but 0, 1 goes up 1. At 1 comma 3 goes here, and 2 comma 5 goes up here. And what we should notice is there should be a line here because we had a linear equation to start with, so we should make a line. If you don't make a line, that means one of your ordered pairs is wrong. So you go back and double check your work. You can go here. It's actually a little bit easier to draw these lines when you are not on a computer. Make sure you are always using a ruler to draw lines. If you are not, I will make you start over. I actually will. Cole Papendick. So for our next equation, we have something that's a little bit trickier. 4x minus 2y equals 4. So first step here is we have to create our table, just like we had done before. So we have our inputs, our x's, and our outputs are our y's. We do our very common table, negative 2, negative 1, 0, 1, and 2 for our x values. And now we have to plug them into the equation, each one at a time. For negative 2, we go 4 times negative 2 and get negative 8 minus 2y equals positive 4. And now we have to solve for our y value. So we're going to add 8 to both sides to give us negative 2y equals 12. Now we divide by negative 2 on both sides. And so our y value is negative 6, which goes right here. Now we have to plug in our next value, which is negative 1. Negative 1 times 4 gives us negative 4 minus 2y equals positive 4. From here, I add 4 to both sides to give me negative 2y equals positive 8. I can now divide both sides by negative 2, and I get negative 4. Now, a lot of people want to jump to the pattern from here, but I would not recommend it because if you made a mistake on one of these first two, you won't catch it. But if you wait to jump to the pattern until you're done with the third value, it actually is a little bit easier to see if you caught a mistake. 4 times 0 is 0, minus 2y is equal to 4. From here, I can divide both sides by -2, and y is equal to -2. And now it does turn out that our pattern was correct. So our next value is 0, and our next value would be a +2. Now we can take each of these ordered pairs and graph them. So I go -2, -6 is down here. -1, -4 is right there. 0, -2 is here. 1, 0 is right there. And 2, 2 is right up there. Now I can draw my line with a ruler. And I always want arrows on both ends of my line to make sure I showcase that lines can go on infinitely. So now we have taken equations, made tables, and made graphs from those. Let's give a little bit more context to what we're doing. So we have a table over here that shows number of eggs remaining if Sydney is making quiches. So if we look at the first question, it says, if Sydney currently has 60 eggs, how many quiches has she made? Okay, so we find our eggs. That's on our y-axis. We go to 60. We go on our line, and we found that right here is where she has 60 eggs. And at 60 eggs, it appears that Sydney has made 2 quiches. And there's no way I'm going to spell quiches right if I don't actually watch the word as I spell it. Okay, 2 quiches. There we go. If Sydney made 10 quiches, how many eggs are left? Okay, so quiches, that's on our x-axis. We go down here. We find 10. That's right there. So if she has made 10 quiches, that means she has 20. Sydney has 20 eggs left. Now the tough question. How many quiches will Sydney have made when she's out of eggs? And I look at my table and I go, uh-oh, that is not actually on the table at all. So we're going to have to use a little bit of critical thinking. And if you remember from last section, I'm always going to say, make a table. So let's make a table from here. So I'm going to have eggs on one column and then quiches on the other. Okay? So here's my table. And let's fill this out with a few values that we worked with here. So I noticed that 50 eggs is the same, or has made 4 quiches. So then I notice also we have 40 eggs is 6 quiches. So then it looks like 30 eggs is 8. So it looks like we have a pattern here. So that means 20 eggs, that'll be 10 quiches. Then we'll have 10 eggs, that'll be 12 quiches. And if the pattern continues, which our line says it does, that means she will have made 14 quiches. And now we have one last problem left before we're done, which before we were working with linear equations, this is a non-linear equation. And the only reason why I wanted to show a non-linear equation here is non-linear equations do not follow the same pattern when you are making the table that others do. Therefore, when you're making the input-output table, you have to be much more careful in watching it. So if our input is 2, input is our x-axis. We go to 2 and wants to know our output, so that's right there. And looks like it is 3. 2, 3 is the ordered pair they want there. And for the last one, says if the input is 8, that's over here, that actually ends up being the same output of 3. And that will happen a lot with nonlinear equations because it will usually have a bend or a bump in it somewhere, so you will end up getting the same output more than once. As always, if you have questions, make sure you let me know. If you did not get a 4 out of 4 or 3 out of 4 in this video, make sure you do the retake.